Before we get going too far, especially because we have access to the full data set here, it might just, I want to talk a little bit about how we check assumptions to make sure that the data is appropriate to run these types of tests. One of the assumptions is that the observations need to be independent, right? They're not connected to each other in any way. This data comes from a simple random sample of mothers in North Carolina. So because the sample is random, I think it's reasonable to assume that the observations are independent from each other. There's this assumption that the data should be approximately normal. There's a bunch of different ways to check this, but for now we're just going to use histograms because we're already sort of familiar with histograms to show the distribution or the spread. So I put a histogram here of the mothers who smoked. We can see the distribution of the data, and mothers who did not smoke, and see the distribution of the data. And you can see that, you know, it's not perfect by any means, but they're definitely a little bit normal looking, right? They're at least unimodal. They only have one mode or one peak, right? And maybe you could argue they're a little bit skewed left, but it doesn't seem too extreme to me. Because I have some experience looking at this, I think this is reasonable to assume the data is normally distributed. It may take you some practice to get used to trying to decide, well, how normal is normal enough. And for now, we're just going to sort of use eyeballing to sort of decide. There are formal statistical tests you can use to test whether something is normal enough. And there's other types of plots you can look at. QQ plots are another way to look at the normality. But for now, I think this is enough to sort of check and see that they're approximately normally distributed. We're going to say it's okay to assume that. And I also don't seem to notice outliers that are too extreme. So I think we're okay to proceed with the hypothesis test.